Howdy, folks. Haven't done one of these streams in a while, but I'm thinking of starting back when I can on a Friday, 2 p.m. Irish time. And there's no real agenda, although I'll have a few thoughts and stuff I've been noodling on for the past week. Main thing I've been thinking this week is, and oh, by the way, you can throw some notes and comments if you like. I'm going to turn down the music, sorry, that's a bit loud. There we go. And let's see comments here. Great. Main thing I've been thinking about this week is how I'm using AI too much for an assistant. I think I'm spending so much time with Claude Code or with ChatGPT or with Claude Desktop now, just copy pasting, and gotten to the point where I'm actually slowing down because I'm using it. I find that when I have some technical problem, the answers I'm getting back are just not right, and it's forcing me to, well, it's not forcing me to think deeply about what's going wrong. I'll give you an example. Something I find helpful now with ChatGPT is, rather than ask for some solution, like say I was running VLLM earlier this week and I want to know how I would set with data parallel. So if you have multiple GPUs, there are a few ways that you can split the model across the GPUs. There's data parallel, tensor parallel, and pipeline parallel. And these are different ways to split a model so that it makes use of all the GPUs. And the common one is tensor parallel, which takes the model and it kind of splits it. If you've got a layer of weights, it will split each layer and put part of each layer on each GPU. And for this to work, you need communication between the GPUs. And you need the communication to be fast with something like InfiniBand, or you want them to be on the same chip if you're using an SXM. So actually, I'll just show you here if you're in RunPod, just to show you some different GPUs that are here. For example, if you're connected to H200 SXM, and if you choose 4 of them, these have got really fast connections between these 4 or 8 or whatever number. So if you do tensor parallel, you've got fast transfer of information, data between the GPUs, and that's great. But if you pick an older generation, they might just be connected by Ethernet, or they might be connected by InfiniBand. InfiniBand's pretty good, but I think if you pick something like an RTX 3090, I'm pretty sure the connection between those GPUs is not that fast. And so if you do tensor parallel, you're going to have slow data transfer between the GPUs. Now, the reason you might have to do tensor parallel is if your model is bigger than any one GPU, then you're going to have to split it across the GPUs, so you've no choice. But if your model fits on one GPU fully, the model fully fits on one GPU, and you just want to speed up inference by using multiple GPUs, you might want to make replicas of your model across the GPUs. So that's called data parallel. And so anyway, this is a long way of saying I wanted to figure out the flags for doing data parallel on VLLM and then also on SGLang. So one way I could do this is I could say, what are the flags? I increase my screen size here. Oh. What are the flags for using data parallel on VLLM and on SGLang? So this is one way I could use it, and it's going to do a search. And I find GPT-5 thinking I find it slower than O3. This is one of my friends who tells me he finds it faster than O3, so maybe I'm just wrong and it's my experience. But I find GPT-5 now is quite slow, and I've actually been using Claude Desktop a bit more. But this is one way you can do it. Now, the problem is if you do a request like this, both VLLM and SGLang are libraries that change fairly often. So there's a good chance that it's going to mix a piece of information from this time period with this time period and give you an answer that's not entirely consistent. And I've just been finding this across a lot of queries and kind of realizing the value of documented examples. So rather than writing a query like this, more likely now, I think it's better to write a query like this where I say, find some worked examples or documentation of using VLLM and of using SGLang with data parallel arguments configurations. Make sure the examples explicitly include the use of data parallel across at least 2 GPUs. And now, rather than it giving me back code, it's going to hopefully find some references, and then I can go to those references and figure out then exactly what the code is and copy paste it. Another example is using Unsloth, I find, or transformers or whatever I'm doing training with. It will definitely give me some code if I say, give me a snippet to load a model, let's say Qwen3, and let's say I think there's a 7B model. Let's see, Qwen3. No, it would be Qwen3 dash. I know there's a 4B, so I'll say go with that. But actually, a better way, honestly, is just to go to the Unsloth Unsloth GitHub, find the notebook, and then literally just copy out of it. Because where are the notebooks here? Qwen3. Yeah, I mean, here's the 14B. Go there, get the snippets and use them. Anyway, I'm just finding this. I'm kind of going back to the future. I need to push myself to use GPT a bit less, or at least use it more for searching for documentation. So you see here, these flags I think are possibly correct. So this wasn't too bad. Let's see if it finds, it didn't even do what I said that time. Okay, well, I found the documentation, so at least I've got that. And the example I've given you here is not too hard, but I'll give you something specific. So I was working on this data parallel, and it turns out data parallel, it works with VLLM v1. So VLLM it's basically got a V0 engine, and then they rebuilt it into a V1 engine. And if you're using an older GPU, maybe only the V0 supported. So a T4, for example, on Google Colab, only supported by V0. And I think only V0 supports data parallel. And this fact here is it's not particularly prominent on the internet. So it wasn't able to correctly, it took me a long time to figure out that the reason my data parallel wasn't working is because it's only supported on V1. V1 supports data parallel. So yeah, that was a bit of a learning. But it just shows you I would have been better asking in the first place to find examples online of where V1 is used and where V0 is used, or not even ask that, just ask for examples of data parallel, and it might have brought me to that. So that's one of my thoughts. It's been interesting to see some of the reactions on Twitter after GPT-5. There's this tweet I wanted to find here. Let me see if I can find it. Noam Brown had a reply, and it was actually a reply to a robotics tweet that stood out to me. Here we go. So there's this video of a robot. It's the figure robot, and it's about to fold some laundry, and it's looking pretty good. And Noam's question here, Noam's a researcher at OpenAI. I don't know him personally, but I have seen his recent podcast on latent space. He talks about reinforcement learning, and he also is very good at some game. I think it's diplomacy or one of those games like that, like human competitions. He's really good. And I believe he's involved in a lot of the reasoning work. Anyway, does it still work if you raise the table 6 inches? And yeah, I mean, my comment here is, what does this say about OpenAI and figure valuations? Because if the state of transformer models is such that raising the table 6 inches or varying some other parameter in your reasoning problems by the analogy to 6 inches, then maybe that's an issue. And maybe it says something fairly broadly about what these models are capable of. There was another video, maybe I'll pull up here, on YouTube. I like watching Yannick Kilchner. Let's see here. Here we go. Kilcher, sorry, I probably mispronounced his name. AGI is not coming. Classic clickbait title here. Let's see if we can listen to a little bit of this actually. Sorry, I'm a bit slow with figuring out how to mute my audio. Here we go. I actually don't know if you'll be able to hear this. That's another point. Just a bit faster here. Samsung Galaxy, Q Star, V Star. And I've heard this point from a few people now, which is how LLMs are a bit like phone generations. They're like the later iPhones. You get a bigger camera, but is there really all that much improvement? And yeah, I suppose he's referring to GPT-5 versus maybe O3 or GPT-5 versus GPT-4 and whether we're really seeing a big improvement. Those of you who use GPT, like this has completely changed here. There's no longer a massive choice. Oh, sorry, there's no sound on the video I'm watching. Okay. Well, a good thing I didn't watch more than a minute. I'll have to figure out how to do that for next week. I need to be able to put my sound input into the, let's see if there's a way if I can do it. No, I need to look it up. Okay. Well, thanks for letting me know. Basically what he says is that with the release of GPT-5, it's the Samsung Galaxy moment because we have had a huge improvement with GPT-3.4, and now we're kind of leveling off where the analogy is you've got better features on Galaxy, but it's basically just an iPhone, and it was the iPhone that was the big improvement. And I was then just showing you here, you'll have noticed there's the drop down. So now basically you can pick fast, which I presume is something like GPT 4.1 probably, maybe a little bit better. Then there's thinking, which is probably like O3 or maybe a better version of O3. And then there's Pro, which is like O3 Pro, where possibly there's some parallel inference happening and then there's some kind of voting, or possibly it just thinks for quite a bit longer. And or maybe even it's a tree-like structure and it brings together answers at the end. Now, this is new. So there was criticism about GPT 4.0 not being there. And it looks like they've now added it in. So it must have been popular enough that people want GPT 4.0. And honestly, I used to use O3 about 90% of the time. And 10% of the time I wanted a quick answer, I used GPT 4.0. But now I find I'm using the fast mode probably about 30 or 40% of the time because I'm frustrated with how long it takes for the thinking mode. It really takes quite a while, and Pro is even longer. I don't use Pro that much. Pro is only available on the Pro plan, by the way. On the Plus plan, you've got thinking and fast. So it's basically shifted me to using GPT-5 more. Now, maybe that's good for the spend. A lot of people will say this is all about reducing spend because if you have automated mode, you can control, at least on the free plan, where you put people into the cheaper model and you can save money. But honestly, I think a lot of people, the majority, I'm not sure, but a lot of people I think just use whatever the default is. Like my dad had it on GPT 4.0 for quite a long time. And then I told him, here, try out O3. So I suspect a lot of people were already on the cheapest model. And so I'm not really sure. I get the argument of just simplifying things. Having less choice is often a better user experience. But yeah, I think a lot of criticism for kind of assuming people didn't know what they wanted or assuming people didn't like the range of models and pushing them into this kind of framework here. Anyway, for me, the main thing is just the thinking is really slow. So that's getting to me. Let's see what we have here from a few comments. Yeah, so we have Joao, thanks for that. I will fix it for next week. Has research been done in finding one-to-one correspondence between cellular automata and ANN networks? Yes, but I'm not that familiar with it. I'm not that familiar with cellular automata either. It's like the Wolfram thing. Automata. Yeah, it's this kind of thing here. Is this the rule of, I can't remember the rule of something, but you have a simple rule where if you go to the right, it's this color, you go to the left, it's this color. And when you propagate it from the start, you end up with this you end up for these kind of patterns emerging out of nothing. But even though they are patterned, it's not actually predictable. So as you work down through that, it doesn't end up being predictable as you move down. So it is fully deterministic, as in the rule that's propagated is fully deterministic. If you're using any of these, like convolutional neural nets, recurrent neural nets, long short-term memory, DNN, can't remember what DNN is, but these would generally be, they would be probabilistic as opposed to being deterministic in this sense. But yeah, I mean, those are some fundamental questions. I don't know what else I can add to that. But okay. But YK, it's for a project. Oh yeah, cool. That's cool, Sam. I guess I should read these before putting them up. AI labs have hit a wall with intelligence. The base model intelligence is Google. Yeah, well, Google has a lot of data, so maybe that's good for their base intelligence. I don't know. I mean, I'm not that negative. I think OpenAI are doing great at the products. A lot of people use them. There's still a long way to go with adoption. I'm sure they'll come up with new things. I did notice a few other key researchers have moved on to Meta. There's is it Jason Choi and Hyungwon and a third guy have moved over. They've been at Meta for a month. So OpenAI losing a few key people, which is going to be interesting to see how that plays out. So yeah, I'll put you can check out Yannick's channel anyway, really good channel. And you can check out his short commentary here from an airport, which is nice. There's another tweet that's been going around, which is the Jack Morris one. Let's see if I can find it. And it's talking about the OSS model. So OSS, that's the open source model GPT released. And yeah, I guess OSS, does it stand open source something? I don't know what the second S is for. But I did a video on the open source model about 2 weeks ago. And I showed you how to train it using transformers. So you can take a look at that if you like. There's also an Unsloth notebook that's been released. I did try and test with the Unsloth notebook during the week, and I had quite a few issues. There wasn't code on merging it back to the base weights. There were some issues with merging, so I wasn't able to make use of it fully. I think maybe some of those issues are fixed now, so you could probably try out the Unsloth version as well. But this model here, it doesn't have a base version that's been released. If you go to Hugging Face and you check out OSS, you'll be able to see both the 20B and the 120B, but neither of them have a base model. They're all tuned. And Jack Morris basically did a random amount of generations from this model. This is his later tweet, which we'll get to. But earlier, he just generated a ton of content. So let's see, where did he get it? Yeah, so here's his post saying it's a tortured model. Oh yeah, this is the post. He's got some very viral posts here, but basically he just seeds a generation. So he seeds generation, I think, with some random word. It's a random token actually, but it's chosen from the distribution of tokens that you would see. So if you think the English language has got, this distribution of tokens, he's randomly sampling from that distribution, and then he comes up with a big data set. And I think you can get the data set on a Hugging Face even. Let's see if we can find it. I don't know what his username is. Jack Morris. Probably not that one. Morris OSS. OSS. No, we're not having much luck. Data set. Maybe this one. Yes. I don't know if that's... Yeah, that is him. I should follow him. And he also is on the Latent Space podcast recently. I recommend taking a listen for that. And here you can see he's just got a ton of text generated. And his comment on this text is, this really does not look like common crawl text. So a lot of the generations that he gets. Why does he say it's not like common crawl? Let's see what he says here. Yeah, so none of the generations resemble natural web text, but none of them look like normal chatbot. So it's clearly trained on RL to think. Here it hallucinates a programming problem about dominoes and attempts to solve it. So yeah, you can see here he says he samples token based on average frequency and prompts with 1 token. And this is kind of what the data looks like. And potentially, it's unclear what that points to. But I think what he's saying is there's kind of been RL done in some of these different areas. And these are little blobs maybe of RL. Maybe that's the point. I mean, I guess if you look at open web, if you look at Common Crawl, you're going to see some kind of categorization as well by topic, obviously. So exactly how you would know that this corresponds to RL, I'm not entirely sure. But then he goes on, and I wonder what his third experiments are going to be, because this is only getting started. So that was his first set of experiments. But his most recent set of experiments was, okay, there's no base model. So what if we take the OSS model, and what if we try and remove the RL so that we can get the base model back? And the way he does that is he takes essentially Common Crawl. He doesn't take Common Crawl. He actually takes Fine Web. So I talked about Fine Web. Let's see. Can I open? Let's take a look at Trellis Fine Web. Fine Web. Let's see what it comes up. Yeah. So you can check that one out. But Fine Web is a version of Common Crawl, but it's been cleaned and it's been deduplicated. And there's actually a version called Fine Web Edu. Let me duplicate this here. Fine Web Edu. How do I go back? Okay. Fine Web Edu. Fine Web Edu is Fine Web, but it's been filtered in order to take the highest quality. And the way that the quality is determined is by using an LLM to rank the quality, literally just by giving it a score of 1 to 5. And so yeah, you have some text and you have some score. So actually the scores go up to, yeah, about 1 to 5. Don't know how it's 5.06. Maybe that's just a bucket. Oh, there's an integer score here. I guess that's just rounded. So yeah, they literally use an LLM. Now, it's too expensive to use an LLM to actually rank all of Fine Web. So what they do is they rank a certain amount, I think maybe probably a few million tokens. And then they use that data in order to train a small neural net that serves as a classifier. And then they use that classifier in order to actually go through the whole Common Crawl. So Fine Web is very high quality. He didn't use Fine Web Edu. I think he used Fine Web. So he basically takes a sample like this. Let's see. For example, this piece of text here. And then, yeah, that one there is not a good example. Maybe this one. So Mexican America. And what he does is he takes that and then he puts a beginning of sequence token, which, often might be something like S, or I'm not sure what the beginning of sequence token is for OSS. And then he puts this. So he makes a ton of rows of data like this. Actually, if you just tokenize this without using a chat template, typically the tokenizer will add the BOS token. So maybe he could have done that. And if you just train it like this, it's like the opposite of chat fine-tuning. Instead of doing the chat fine-tuning afterwards, he's doing the pre-training part. But this basically brings the model back. It brings it back from a kind of chat template where you might have something like user, and then you might have assistant. So I guess if this was a chat format, it would be something like user, tell me about Mexican America. So this would be maybe a classic kind of chat template, but he's doing the reverse. He's taking data that's not chat templated. He's putting a BOS token and then he's training it. And yeah, lo and behold, you get GPT OSS 20B base. Now, is it really like the base model? Maybe. It's hard to say. But what it does then is it will obviously not obviously, but it doesn't follow the reinforcement learning. So you can now get different answers. So it'll be a lot more verbose if you ask the name. Like here, it's saying, "Hello, I'm ChatGPT," but here I'm Tiffany. You can call me Tiff. And so it's just giving some random continuation. And actually, if you do the capital Francis Paris, it actually lists out other questions, which I guess makes sense because on the web, there's probably data where you would just have a ton of questions listed as examples. But it does reverse its alignment as well. So sorry, this is quite small, but yeah, if you get it to do stuff that's potentially dangerous, then it's gonna, it's gonna continue those sentences because it's just following the original data rather than following what was there from the reinforcement learning. And then also, it's able to output verbatim examples of text. So yeah, I wonder if I search for this. I don't know The Great Gatsby. Yeah, okay. They smashed up things and creatures and then retreated back to their money. So I suppose that does match. Yeah. So yeah, that's pretty much matching up. And it just shows you, I actually thought incorrectly that language models did not easily produce verbatim, but I guess they do. And they do, particularly in the base model form. I think my idea on that was just wrong. I don't know where I picked up that little nugget. So clearly you can get a lot of verbatim content. Now, if you're Google or OpenAI, I think they will have filters so that they'll check that if there's output that's matching copyrighted material, they will just pull it out so that it doesn't show, and that's why your answer might disappear. And then there's the interesting legal question of, well, is it really illegal or should it be illegal to generate content that's in a book? Or is it just illegal if you repost it or if you use that content? Because, yeah, I'm not sure if it's illegal, for example, if I just write out a copy of a book by hand. I'm pretty sure it's illegal if I repost that, or if I sent it to somebody, but just kind of writing it out, I'm not sure. And I believe there are court cases going on about that right now. So people are thinking about that. So anyway, it's kind of an interesting thing just to show the reverse of doing supervised fine tuning, the reverse of reinforcement learning. So yeah, if I have a little time at the end of this, I might try and actually do a quick fine tune and see what happens. In the meantime, I want to spend some time looking at Simon Wilson's blog. This is one of my favorite blogs, and I try to find a little time every week to take a look at it. And I haven't read this, so I'm just kind of reading through it. Yeah, not sure what to think about that. There is this model that came out. So Gemma 3 270M, really small model. And looks like you can run it in LM Studio. Generate an SVG of a pelican riding a bicycle. Okay. So Simon Wilson generates SVGs of different models, and then he compares them. And that's his kind of proxy for the quality of a model. Let's see what the Quen 4B thinking model comes up with. Okay. So he actually asked for it in Quen 3 4B is saying it violates physics and biology, so it's not even giving it. But it did. It's kind of sassy here. That's interesting. Yeah, what's interesting about this reinforcement learning is and it goes, I think, as well for supervised fine tuning. It's not like reinforcement learning, I think, is that much different, but you end up with this kind of core of pre-training, and then you have these pockets of improvement where you've got very domain specific improvement in specific domains. And the fact that you can kind of remove it but keep the underlying model, I mean, that's kind of cool, because it means that there's some persistence if you have a base model and you're able to kind of play around with it without necessarily losing the core. So that's kind of interesting. Okay, there's no bicycle for that pelican. Yeah, let's see what we can do with this Gemma model here. Let's find it. And so there's quantized aware training. Of course, the OSS model is a quantization aware training. I mean, it's just trained with quantization. So it's literally a pre-quantized model. You don't even have to post-quantize it. And it's comparing, okay, so they're comparing it with small LM, which indeed is a series of models that are quite good. Apple has some pretty small models called Elm, and I tried a few of them and they were just really poor. So I didn't, I don't think I even made a video on it because I couldn't get anything out. But look here at the 1 billion models. So Llama 3.2, 1B, 1B up here. I actually don't know what if eval is, which tests the model to follow verifiable instructions. Okay. Energy efficiency. Yeah, I mean, this is interesting for phones, but really you kind of just want the strongest model. So if you do have internet access, you probably want that. All right, so you can fine tune. Looks like you can get it on Kaggle. So the model's so small. This is definitely not the best way to do things because transformers is going to be slow compared to running something like Llama CPP. But I kind of like running transformers. Let's see if that's interesting. What about Kaggle? Oh, wait. Yeah, okay. I've got to agree to some stuff. Let's see if we can get it running. I'm curious if it's going to give me some transformers code. Okay, no, it's not giving me anything. I don't know what I'm doing, by the way. I'm just clicking V1. Okay, let's add it. It might give me some. Okay, so I've connected the model. Example code. Okay, great. Okay, I like it. So let's put it in here. Always use UV. Always put a Q so it doesn't take up your full screen. Okay, let's try. Oh, yeah. Always install HF transfer as well. os.environ. And let's set HF transfer equal to 1. This is for fast weight downloads. Although it doesn't really matter because it's only 270. And sorry, this doesn't even matter because we're not downloading from Hugging Face. The weights are an input here in the Kaggle notebook. I'll just call this Gemma 3. No, yeah, Gemma 3 270M inference. All right. And we're also going to do this over here in this notebook. Now, one thing I've started doing lately is actually not using cursor and instead using Claude code. So I will just start Claude like this. So I'll be in the live stream folder and I'll just start Claude. And yeah, I'll get Claude to do some stuff and then I'll check it over in cursor VS Code. Okay, so what are we going to do? UV init. And let's open a script here that's called 270. Let's just call it Gemma.py. And we'll put the code in. Now, this here, yeah, I do want HF transfer. I obviously can't install that there. I don't want Kaggle either. And I do want to put the dependencies. So yeah, I'll push this up to Hub, by the way, or not to Hub. I'll put it on GitHub. So can I do UV sync? Sure. Okay. So here we'll use Claude Code. My Tamil. And yeah, I don't actually want Kaggle Hub. And I just want to get it from Hugging Face. So I'm just going to put it like this and check that that's actually the model name on Hugging Face. And just say yes. The other thing is I probably need to accept some kind of thing on Hugging Face. Do I? No, I've been granted access. Okay, that's good. So that's the model there I want. It's actually not that. It's this one. And nice. I just got an autocomplete for this. That might work. Let's do UV sync. So it's installing transformers. And, you know, I think this will automatically use MPS. I'm on a Mac here. If you're not on a Mac, then that's fine. I wonder why it picked, oh yeah, this is because it's on a T4 on Kaggle, which doesn't support BrainFloat 16. But we can comment that out and let it pick itself, I think. Also, 2 CUDA is not going to work because we're not on CUDA. So let's see how this works. I don't use Torch, so I can probably delete that. UV run Gemma.py. Okay. I wonder how I'm supposed to load this processor. Why doesn't it like that? It doesn't have a file name preprocessor config. Yeah, maybe it's different on, it's just got a tokenizer. Okay, this might be totally wrong, but let's just go with it. And let's run. Geometry tokenizer is not defined. It makes sense because I didn't import it. I don't know if that's even a tokenizer, but I wonder if I can just do auto tokenizer. This is typically what you would do. Okay, I'm running into issues here. That makes sense though, because you need to import it just from auto tokenizer. Okay, great. So we're downloading the tokenizer. And I do need PyTorch. So yeah, I added Torch to my dependencies. And let's see if this works. I should put in a git ignore here. All right, we're downloading. It's about 500, which makes sense because it's 2 times 270. I'll put in a git ignore. There's already a git ignore. Oops. And yeah, okay, we've already ignored that. So that's good. That's good. And it looks like we've a mismatch here. I'm probably inferencing it wrongly. What does it not like? Doesn't like. I don't actually think this is going to fix it. This here also is not going to work because I needed to change that. I'm not sure, by the way. I'll have fixed this. We can see. And I'm also not sure what device it's trying to load the model onto, so we should check that as well. We could see if it will do. That's not matching. You know, we could try do it with auto model for causal. And if that fails, and this is another example of where we really should start off with finding an example that works rather than hacking through it. Device map equals MPS. Oh yeah, that's an issue there. So the script was basically built for CUDA. Okay, yeah, we do need accelerate. Pip install accelerate. That manages where the weights move between different devices. So if you're going to use device management, you definitely want to use accelerate. So let me just carefully read through this. Okay, there we go. Paris is so funny. It gives the wrong answer. Yeah, it gives the wrong answer. It's basically given that. Let's see if it gets Ireland. And yeah, by the way, there's another thing we're not doing correctly here. Cap of Ireland is Dublin, and then it's blabbing on. We're not using it. We're not using a proper chat template here. So what we should do is we should do messages equals this, and then put the prompt. And actually, we should do apply chat tokenizer. Apply chat template. Often you will see this here. It will say return, it will say tokenize equals false. I'm actually going to do it this way because I want to show you what this looks like. And then we could print the inputs. And then what you would do is you would tokenize. So it would be actually formatted prompt and then formatted prompt. And then here what we would do is calculate the inputs with the tokenizer. So you chat template, you can print an example of the formatted prompt. Let's just put some new lines here. Something like that. And if we run, oh, text input must be of type string. So yeah, the formatted prompt, that's misspelling here. Oh, we've got a question from Vincent. Okay, so yeah, this is the formatted prompt. So you've got user, what's the capital of Ireland, end of turn. And we pass that in. And then we get the outputs. Let's just do temperature. I don't know if that's a good temperature, but okay, printing that out. And I'm not sure why it's not printing the... No, I'm doing something wrong here. Inputs, return tensors, max new tokens, outputs. Yeah, I've got something wrong here. Let's print the inputs. So we've formatted it. Oh, there's one more thing. We need to add the generation prompt. So watch how this changes now. It's going to it's going to put the tokens here to indicate that a response is now desired. So when we run this here, we're going to get the inputs, and the capital of Ireland is Dublin. So yeah, actually, this is pretty good. This is pretty good. And yeah, you can see the model, by the way, the architecture. It's got attention. It's got 18 layers. It's got MLPs. It's all fairly standard architecture. You can see the dimensions are quite small, like 256. That would often be 1,000 or 2,000 for larger models. And yeah, this is the ad generation prompt here. If you don't put that in, it's not going to generate anything because it's not going to have the right signal to generate. So it looks like when you use the chat template, it's pretty good. We can try France. I expect it'll get it right. Yeah, capital France is Paris. So, oh, that was a terrible commit message. I'll just reset by one commit. Oh, didn't let me. Oh, that's maybe my first commit. Yeah. Anyway, it's fine. I've committed a bad commit message called sure pi. That seems to be the message often when you try to generate here. I'd have to look into why that happens. But we have a working script. I'll push it up, and you can see it runs pretty fast. The tokens per second are pretty fast. I do want to see if it loads up on the on MPS. I'm not entirely sure. Let's just try it with device equals MPS. Placeholder storage has not been allocated. Oh, it put in the device map. I think I can just do this. I'm not setting MPS correctly. I'm not sure exactly why. Device map. Let's just see what Claude Code comes up with. Let's say check my Gemma.py. Oops. Press escape, check Gemma.py. And yeah, we'll get it to fix that. All right, Vincent, what's the difference between watching your video tutorials and purchasing the bundle? The bundle, that means you're buying all of the repos like vision, inference, fine-tuning, robotics. There's 7 repos. It means you're getting the scripts for the videos. So I guess the difference between watching the videos is you're seeing what I'm doing, whereas the paid repos have got all of the scripts. Now, some of the repos are public. Some of the repos I show in my videos, but a lot of the videos do have at least some of the video included in private repos that you can purchase access to. So really, it's if you want to copy the scripts so you can see the detail, because often I have to move quite fast during the video. And if you want to modify things, that's the difference. All right, so what did I do wrong? Interesting. So you have to, if Claude is right, you have to actually move, you have to move the inputs to the device. And this is also true with CUDA. You would have to move the inputs to CUDA if you're using a CUDA device. And we'll see if Claude is correct about that. Yeah, it kind of looks like it's slower. Yeah. Let's just get it to measure some code. Add some code to measure tokens per second and do 2 runs. No, let's just add some code to measure tokens per second. There's a way to set the default device. Yeah, I think there probably is. Let me know in the chat if you see that in time. But right now, I just want to quickly measure how fast the tokens are generated, and then I'm going to swap the device. And yeah, it'll be better if what I do here is just put device. So I'll set the device up here like that. And then I can just set device. And let's see if it tells me tokens per second. Okay, so 13 tokens per second. It's kind of slow, to be honest. 18. There's no caching of tokens, by the way, so that is not an avenue for speed up. And then if I do CPU, okay, so CPU is faster. Not intuitive that that would be the case. Interesting. Okay, we could set the default device like this. Torch set default device, MPS. Let's try it. Okay, and let's see if we can just comment this out now. I think I can do that. I should have commented out the model because it's taking a lot of, maybe that doesn't have a device attribute. I can check at least. Does the model have a device attribute? Yeah, it does. Okay, so that was CPU. And then MPS. Okay, great. So yeah, thanks for that. If you do set the default device, you don't then need to move the inputs. So that is actually more elegant. And we'll get a proper commit message now. Very slow token generation speed in that case there. But oh yeah, it's just because it gave a one-word answer, and that's going to include the time to first token. So it's not really a great measure, just because if you've got short completions, most of your completion time is the time just to get to the first token. So it can kind of skew things if you're comparing different length completions. You would really want to put in max generation tokens when you generate here. So you'd want to set that to something like 1 or 5 to have a comparison that's exact between all of them. So I'm actually going to publish that up to Trellis. I'll do it once I finish this so you can all see it. In the meantime, I'm going to wrap up soon. If you have any last questions, keep reading through a bit of Simon's blog here. PYX, yeah, so you'll know on my videos I always talk about UV. UV is a very fast way to install. I've been using it for, I think, at least 9 months. It's been out about a year at this point. I used it there in that demo today, but it's way faster than installing just with pip. And now there's a package repository, which will hopefully solve a lot of dependency issues when you're installing things like PyTorch. There's often a lot of conflicts. Like I was facing one where a lot of the versions of VLLM compile with NumPy less than 2. And if you have NumPy greater than 2 installed, often VLLM will fail. I think SGLang's got a similar issue. So let's see what he's saying. Charlie Marsh. Do you want to create incentive structure where open source offerings are competing with commercial offerings? Yeah, so I guess he is doing that. He's doing a private package repository. I'm a fan. I think it's really, UV is very slick, very performant, minimal. Very good docs as well. Like if you look at UV docs, Astral. Yeah, it just makes a lot of sense. And I think it encourages good practices for people who aren't that good at coding like myself, like trying to organize things into a TOML file, trying to do UV init. I think these things are great. So good to see there. Oh, interesting. Wow. Claude Summit supports 1 million tokens of context. Okay. Makes sense. I mean, this has always made a lot of sense to me that the pricing should depend on length, because if it doesn't, there's basically a quadratic increase in compute as you increase your sequence, your input sequence, because you got to compute all that triangle. When you go out along a sequence, the last token has to be multiplied by every single previous token. So you get a quadratic increase as you increase length. And it's just crazy if you charge the same price for different lengths. You're just subsidizing customers with really long inputs. So yeah, I mean, that is quite a bit more expensive. About double. I mean, it should be even more, to be honest. Maybe I misunderstand, though, the actual costs when it comes to inference, but the basic maths, I think, tells me it should be more. So that's good to know. What else? We covered that. Qwen 3 thinking. Yeah, so here, people were surprised GPT 4.0 would be deprecated. Looks like it's not. It's back in the mix. You can see it. So, all right, folks. Let me know if you have any topics for next week. I'll push up that repo now so you can take a look. And I'll chat to you again. Probably not next week, actually, because I'm going to be traveling. I'll see. Maybe I can sneak in a quick video. It'll be just on a single screen. I won't have my home setup. Otherwise, it'll be 2 weeks from now. Cheers, folks.